Are you talking about this one, Sky? Sky? Are you talking about this one? How far? I thought we finished that one. How far did you get on? Oh, okay. Shh. So you have to tell everybody else on what? Huh. Okay. Did we? I feel like we finished, or maybe we didn't, but I finished it in my brain. Did we do number 5 on the review? No, no, no. On this review. Okay, we did this, right? Okay. Did we do number 6? Okay. I think we stopped after 5, and I think here's why. I think Okay, well that's Janessa. And that's Mylena, yeah. Okay, R6 is not something that we want to do. Okay, we skipped R6, but let's do this next one, C1. I'm a little bit worried about us making it through it together, but I'm sure if Olivia and Danica help me out, we can get it done, all right? Okay, so I don't know. Figure 4-7D shows a pendulum hanging from the ceiling. The pendulum bob traces out a counterclockwise circular path with a radius of 20 centimeters. And so they're pointing out for sure that you understand that the only reason that looks like an ellipse is because of the perspective of the drawing. But it's 20 centimeters each way, so it is definitely a circle. At any time t in seconds since the pendulum was started in motion, the pendulum makes a complete cycle in 3. Okay, so it goes around in a circle every 3 seconds. Okay, all right. Assuming that the pendulum bob was at the point 20, 0 at time t equals 0 seconds, so it's going to start right here at 20, 0. Write parametric equations for the circular path that it traces. So parametric equations means x and y. I feel like the center of the circle is at, yeah? C1. No. Okay. The one that you got assigned we'll do as soon as we finish this one up. But Sky pointed out that we had a couple of problems left to do on this. The middle is just 0, 0 because if you look at it, it's just 0, 0. So I think that the equation would just be 20 cosine t and 20 sine t, don't you think? Because it's just 20 each way. I'm not sure where the 3 seconds comes into play yet. That means that it should make the complete cycle. Ooh, let's mess around with that. You guys will love this. You're gonna love this. No, you love this. So let's go 20 cosine t, and then let's close that up and go 20 sine t. Okay. Emily? Emily? Are you paying attention? Okay. Cody? Are you paying attention? All right. So if I go from 0 to 3, you see I've not made the entire circle, but it says that I should have in 3 seconds. So that means I need to change, but I can't change the time because it wants a complete circle in 3 seconds. So I'm going to try, not the 20 because it needs to be 20 each way, but I'm going to change the t. Okay, so let me try divided by 3, just for funny. Okay, so that's bad. That's less, right? Gus? 3t. What if I mean, go ahead. Oh, maybe. All right, that's a really good idea. Let's keep that in mind. But first, okay, change that to 3t. Okay, the question though is, did we need to go, yeah, exactly. Did we overlap a little bit? So let's bump this down to 2.9. Yeah, so in 2.9 it would have completed the circle. So, oh, you think so? Enhance. Oh, no. Right. Right there. I agree with you as well, Janessa. You are a quality student. I think we got it, though, I think. But what if we change this to 2.8, 2.7, 2.6, 2.5, 2. Are you guys having as much fun as me? 2.2, he says. How about just 2? Well, 2 obviously didn't make it 2.1. Huh, that's weird. Where's the cutoff? Okay. Oh, 2.09 didn't do it? Oh, but 2.1 does? Okay, anyway, that doesn't matter because that has to be 3. We know that already. So, the question is what I have to change this to? Just what? We did just t already. A negative t? I think a negative t just means it goes around the other way. Yeah, see? Yeah, it's going this way instead of this way. Okay, so we need like a little bit more than twice this one, right? We can't change the time. So what I'm saying though is if I put 2 in here, I bet it's not going to be quite go all the way around. Yeah. 2.2. Yeah, they do. Oh, they do have to be the same. Okay. 2.1. Well, what if we go 2.09? Oh, Janessa wants the enhance command to come back. Oh, yeah, you're right. You're right. Okay. No, I'm going to go ahead and just say that good enough for us is 2.1. 2.98 is... Okay. Okay, 2.1 looks like it connects. All right, so let's make this not be t. Let's make that be 2.1t. And then it'll go all the way around in the 3 seconds, right? Parametric equation for, okay. Love that. Thanks for your help, Janessa. What? Oh, sorry. It says 20 cosine 2.1t and 20 sine 2.1t. Okay? All right, next question says, where is the pendulum at time t equals 5? Well, all we need to do is plug 5 in for the t's. So x equals cosine of 2.1 times 5. That'll give us the x-coordinate. And y equals sine of 2.1 times 5. That gives us the y-coordinate. So let's go here and go 20 cosine 2.1 times 5. And let's go 20 times sine of 2.1 times 5. Okay? So there's the coordinates of the point where it would be after 5 seconds. Negative 9.5, negative 17.6. Didn't really say. Okay? So I went with 1. You're a better person than I am, Gus. You went with 2. More accuracy is usually better. All right, part C. Find the first 3 times when the pendulum bob, hi Bob, has a y-coordinate of 10 centimeters. So that means we are going to take this equation, sine of, whoops, oh, I screwed that up. At least I'm not on my phone. What did I do wrong? I didn't put the 20s in front. Yeah, this is supposed to be 20. I did on the thing? Okay, thanks. Good. I'm glad. All right, so then to figure out the first 3 times when the pendulum bob has a y-coordinate of 10, I'm going to go 20 sine of 2.1t and set it equal to 10. Because I want to know when will the y-coordinate equal 10. Okay? So I start out by dividing by 20. So sine of 2.1t equals 0.5. And then inverse sine both sides. So 2.1t equals the inverse sine of 0.5. What mode should we be in? I think we're going radians here. Because our... you're right. The way that I would know that is because when we did the graph that gave us the equation, I was in radians. So it's still what? The inverse sine of 0.5 is 0.5? Oh, okay. Well, you didn't say that. 0.52. So 2.1t equals 0.52. Oh, and then we have a plus 2 pi n. Okay. And then you divide by 2.1. Well, because it's going around in a circle, Gus, which is 2 pi. So you have to, we've been doing that. Whenever you do an inverse sine or an inverse cosine or an inverse... Okay, then I have to divide everything by 2 point... Mylena, what are you doing? Stay out of my stuff. Good Lord. What is wrong with you? I don't either. Okay, so t equals, did you get this to? 0.24 plus what? 2.910. Okay, thank you. All right, so it says find the first 3 times. When's the first time? Yep, the first time would be when this is 0. So 0.24. Well, because it says time, so I know I want it to be positive. And then it says the first one, so I'm just going to start with the lowest positive one. And then you add 2 point... that's a familiar number. Then it's what? 6.04. Okay. Nope, says what are the first 3 times. So we're done.
It is so hot in here.
Yeah. No, I do not plan on doing that. I don't know why you said that. Somebody said, can you turn the heat down? And I went and turned the heat down. Why are you comparing me to Mr. Bates? No, I said no to this problem. I don't want to do that problem. Okay, next one. Prove that each of these equations is an identity. Gotta love this. 1 plus sine x plus that stupid quiz that most of you got more than 100% on and probably raised your grade more than any other assignment we've done in this class. Yes, that stupid quiz. Kind of figure out how to get there. I just turned it down. Thanks, Mr. Bate. I don't like this very much. And in order to make the common denominator, you have to multiply those denominators together. Okay? So that means that this is going to be 1 plus sine x minus cosine x times sine, which isn't that bad. That's not the bad part. If you think that's bad, wait till you see what happens in a minute here. So that's our common denominator, right? So what do I have to multiply this stuff by to get this as my common denominator? Sine of x, so that means I have to multiply the top by that also. Okay, not so bad. 1 times sine is just sine. Sine times sine is sine squared. And sine times cosine is just sine times cosine. Okay? Here's where things get bad. No. You think they have. You have no idea how bad things are going to get. Exactly. Right. Because I have to multiply this stuff here by this right there. Yeah. So I have to go 1 plus sine of x minus cosine of x times 1 plus cosine of x. So I'm going to do this in the old school multiplication way. Like if you go 532 times 15 and you write it like this. So I'm going to do all of these by cosine first. So cosine times 1 is cosine x. Cosine times that is cosine sine. And then that times that is negative cosine squared. Okay? Then I have to multiply them also by 1. 1 times that is negative cosine, so I'm going to write that under the one that I already have. And then I also have a plus 1 and a plus sine. Okay? I can cancel those cosines. Everything else is no good except when I put these together, I'm going to have cosine x sine of x plus sine of x, and then I have this plus 1 minus cosine squared, right? What is equals sine squared, right? Good. So I can change this into a sine squared, and then I believe that's what I have there. And so this right here is the same as that right there, so I'm done. Yeah. Wasn't too awful. Yeah. Oh, good idea. Good idea. This one feels like the same exact thing, but the sines and the cosines have been switched, so I don't want to do that. Okay? All right, and then the last one of these. Square of a sinusoid problem. Okay, so the dashed line on that graph is cosine, and then the solid line is cosine squared. Okay? So first of all, it says assuming that the graph of y of cosine squared is a sinusoid, find its period, amplitude, sinusoidal axis, in other words, how far up or down did it go? Where's the middle point? And phase displacement. All right, so what's its period? How long does it take for cosine squared to go, remember it's the solid one, and complete one cycle? What? Pi? What's the amplitude? 1. I knew you were going to say that. Good. 0.5. Yeah. Remember the amplitude is half the distance between the high and the low. Okay. It's in the middle. Yeah. So the sinusoidal axis will also be 0.5. And then the phase displacement is 0. Man, you know what, Sky? You probably shouldn't even bother taking the test. Just a waste of your time. Obviously, you completely understand all this material, so you just get 100. Okay, next one. Write the particular equation of the sinusoid you described in part A. So that would be y equals 0.5, because that's how far up it moved, plus, yeah, because the amplitude is 0.5, sine, oh, you want to go cosine? No, let's go cosine, because it starts at the top, yeah, and then goes down. So let's go cosine. It's not going to be cosine pi. Remember that b is, we're doing radians, but b is 2 pi over the period. So we figured out the period was pi, so it'd be 2 pi over pi, which is 2. Okay? So just x, yeah. Okay. All right. Give numerical and graphical evidence that the sinusoid in point part B is the same as cosine squared. So if I graph these, I hope not, because that's hard. How am I going to know what? Oh, the graphing part, you mean? Let's see. They said, no, I won't ask you to do this on the test. And then we came up with 0.5 plus 0.5. We went with cosine, right? Cosine 2x. Okay, do those look the same? We have to do Janessa's game, though. What am I supposed to say? Enhance. Oh, that didn't enhance. Enhance. Are they right on top of each other? No. Yeah, pretty much. And then if we wanted to show, like, in a different way, give me a number for x. 1, I heard very loudly. If I plug 1 into there, and then if I plug 1 into here, then I get, whoops, sorry, 21. 2 times 1. If I plug 1 into there, then I get the same answer, okay? So graphically or numerically, they're the same. It's kind of weird. 0.5 plus 0.5 cosine 2x is the same as cosine squared. Okay, can I have those from you, please? Or do you want to keep them for the test on Thursday? All right. So, no. For funsies? Okay. Assignment that I left you guys to work on Friday. I'm sure you worked very hard on that assignment while I was gone. Do you want me to just go through the ones you had questions on, or you want me to all of them? All right, here we go. Number 1, write the Pythagorean property for cosine and sine. Sine squared plus cosine squared equals 1. Well, I started writing it and then you guys said it, and so I said it the way you said it, not the way I wrote it. But it really doesn't matter, because addition is, yeah, it's the same. It's commutative. Right? A quotient property involving cosine and sine. There's 2 of them. No, just sine and cosine, I think. There's 2 of them. I guess you could, but I think all they're looking for is that tangent equals sine over cosine. I think. Yeah, that's a valid equation, but I think, yeah. Write the reciprocal property for cotangent. So cotangent equals, okay. Right, but I guess that's not a reciprocal property. That would be the quotient property. So this is probably the one that they're searching for there. Write the reciprocal property for secant. All right. Oh, the value of inverse sine of 0.5 is 30 degrees. Write the general solution. So theta equals 30 degrees plus 360 pi. I do not sound like the Grinch. I do not sound like the Grinch. What? What?
When you're in a bad mood, you ask. You're a mean one.
You talk to your other teachers this way. Okay, the value of inverse tangent of the square root of 3 is pi over 3. Write the general solution for arctangent of that. So then you guys should have in your notes somewhere for tangent. It's 180, not 360. Is it plus or minus? It's just plus? Okay. So pi over 3, but this is not 180 because it's got pi's. Good. Pi over 3 plus pi n. Kai, come on, man. Don't be that guy. I know, so that means you pay more attention when you ask questions. Okay. Well, then you keep trying. You don't give up. There's no quit in you. No, that's what you don't do. All right, explain why the range of y equals inverse cosine is from 0 to pi, but the range of y equals inverse sine is negative pi over 2 to pi over 2. I guess the reason why is that's the way it goes in order to make the inverse functions, inverses the functions otherwise. In order to make the inverses be functions, you have to restrict them that way. Who's that here? Claire at Austin? Is that it? I didn't know you were a redhead, Jeff. Okay, find geometrically the exact value of the cosine of the inverse tangent of 2. Okay, so inverse tangent. I guess it doesn't matter because this is positive, and when it's positive, you're always going to be in the first quadrant. So I'm going to draw myself a little triangle here in the first quadrant. And if I know that the inverse tangent of that angle is 2, then what is the opposite side and the adjacent side? Tangent is what over what? Opposite over adjacent. So if the inverse tangent is 2, then the opposite side has to be 2 and the adjacent has to be 1, which means that, that the other one is the square root of 5. And so now, what is the cosine of that angle? 1 over the square root of 5. We use the stuff inside the parentheses to draw the triangle, and then we use the triangle to answer the stuff outside the parentheses. Why is it what? Oh, yeah, because, yeah, exactly. Pretty impressive. Does that make sense? Okay. She's going to get like a C minus. All right, next one. Transform 1 plus sine A times 1 minus I into cosine squared. Easiest problem ever. What was rude? I didn't tell just you. I told the entire YouTube universe. Good thinking. I apologize. I was trying to be funny. I apologize if my poor attempt at humor offended you. Okay, so if I FOIL that, what's first times first? 1. What is outside times outside? Outside times outside. Outside times outside. This one, thank you. This one times that one. Those are the two outside things. What is... Okay, good. and then the last and the last minus sine squared a. Okay, so that's just that thing foiled out. And then we know it's minus plus, yeah. And then we know that 1 minus sine squared a equals cosine squared a. Okay, next one. Prove that tangent b plus cotangent b equals that stuff. All right, so we had lots of different strategies to solve these. One of these was when you are faced with parentheses, get rid of them. Another one is if you've got just some things, then turn them into sine and cosine. So what is tangent? Sine over cosine. Okay. Okay, then another strategy that we talked about is if you have two fractions. We did this already on the other one. What? Make a common denominator, yeah. And so the common denominator here is going to be cosine b times sine b. Nope, because multiplication works 2 times 3, 3 times 2. All right, then this right here, okay. Nice. I like to hear that. Because she doesn't love me. Okay. Multiply the numerator and denominator by the conjugate. Okay, so we're going to take this. This is not a problem-solving strategy for these that we've done before, but they are telling us what to do. It's saying multiply the numerator and denominator by the conjugate of the denominator. That word means, yeah, change the sign. So instead of going 1 plus cosine, go 1 minus cosine. We're going to multiply the top and bottom by 1 minus cosine. You guys might remember doing this with square roots. If you're like 3 plus square root of 2, then you multiply it by 3 minus square root of 2, and the square roots cancel. This is not something that we've done before. This is a low stress situation here, okay? If I distribute the sign, I get sine of c minus sine c cosine c. And then do you guys just know in your heads what 1 plus cosine times 1 minus cosine is going to be? If you FOIL that out, what you get, because one's a plus and one's a minus, we're going to, yeah, you're a step ahead of where I want to be. It's going to be, right, it's going to start out by being 1 minus cosine squared. Because if you, no, you're right, but because if you FOIL it out, there's going to be a plus cosine, there's going to be a minus cosine, and those will cancel. Okay? And then, like you guys are noticing, 1 minus cosine squared is, in fact, sine squared. Okay? Again, I don't want you guys to stress because this is not a problem-solving strategy that I've gone over with you. Okay? But what we can do on the top is we can factor out a sine of c from both of the terms. And if you factor sine of c out of here, what are you left with? 1. And then if you factor sine of c out of here, what are you left with? Negative cosine. Okay, and then what happens with that is this sine of c can cancel with one of those, and then that leaves us 1 minus cosine of c divided by sine of c. Okay? Okay? Again, that's not something that we've really been through before, so. Hey, Maddie. What's up? Is who? What did she want? Yeah, we skipped number 12. Oh, okay. All right, with your calculator in degree mode, this is you guys. Find the value of inverse cosine of 0.6. So in degree mode. No, we skipped 12. Yeah, he's 53.1. Is he underweight? You guys good with that one? That's a pretty easy one. Oh. Okay. Hey. Pay attention. This is a good one. We want to find another angle besides 53.1 degrees that has the same cosine as 53.1. Okay? Cosine is the We're almost there, but not quite. Cosine is the x, right? So you need to draw another angle that has the same x as this. So if I reflect it this way, that's no good, because then the x goes from positive to being negative. Okay? So I have to flip it this way. Yeah. So I need to make this be a 53.1 degree angle. However, that's not how we measure angles. We always go from the positive x-axis and go around to the side. But you can figure out, if this is 53.1, we can figure out what the blue angle is. How do I do that? Okay, good. Emily, what'd you get? 306.9 degrees. Okay, so you can check this. This is a problem that you should not get wrong, because on your calculator, if you go cosine of 53.1, you should get 0.6. And if you go cosine of 306.9, you should also get 0.6. Okay, and if you don't, then you did something wrong there. Okay. All right, we good there? Okay. Write the general solution for the inverse trigonometric relation of that. Show how you can use the plus and minus sign. Okay, so cosine has the plus minus stuff, right? So we're going to go plus or minus. Was it 53.1?
Yes.
53.1 plus 360 n. Okay? And I guess what they mean is use the plus or minus sign instead of writing that as two separate answers. Yep, that's just the answer. Yeah, that's why I have a job. If they made like good math books that you guys could figure out on your own, you'd be like, I don't need you. I know. All right, so we're starting with plus or minus 53.1 plus 360n, and we want the fifth positive value. Okay? So the first one is going to be when n is 0, and that's 53.1. Okay? The second one, this is going to be maybe a little bit confusing for you guys, is when n is 1, but when this one is negative. And that's the one that Emily found for us. That's what you said out loud. 360 minus 53.1. That's from that drawing that we had over here. That is 306.9. The third one is when n is 1, but yes, this is positive 413.1. Okay? The fourth one is where this is 2 and then this is negative again. So now you're going to go 720 minus 53.1. No way, really? Uh-oh. 666.9 degrees. No, I think it's a cosine that we shouldn't take the test. Oh! Okay, and then the fifth one, which is the one that we're looking for, is when n equals 2, but this is positive. So that would be 720 plus 53.1. So that is 773.1 degrees. I think so. I think the next problem is going to be some weird new different thing. Yeah, okay. So we'll start on problem 17 tomorrow. Does anybody want the practice test right now so that you can work? Okay, so I'll give you guys the practice test before you leave.